Let's start immediately. After my morning speech, you might guess from where it comes, this presentation. But here we are focusing under the food aspect in particular. The authors are Johannes Hilscher from Deutsche Kaffeeverband and Gregory McGaffin and Oliver Schuss-Hermann that are also here with us today. And I thank them for the collaboration. First of all, what is methane chloride? Methane chloride is an organic solvent. CH2Cl2 is the chemical formula. It is used in closed circuits for the production of pharmaceuticals, fine chemicals, polymers, drug and herbal extracts, pharma and food industry, and obviously for decaffeination. Obviously, in the sense, I'm here for especially for that. It is used also for production of adhesives, road marking paint, cleaning fluids as a laboratory solvent also, and the estimated production is more or less 200,000 metric tons per year. Of these 200,000 metric tons, we are really very marginal contributors in consumption. This is something I would like to underline because the issue with methane chloride is not a food issue because of its intrinsic properties. It evaporates at 40 degrees, so you can imagine it's extremely easy to recover. Plus, it has highly selective properties towards caffeine, so it's an excellent decaffeination solvent. You need to use it very carefully on the side of environment and working safety, but it's something that we decaffeinators working in a closed circuit, we all do very carefully. In my case, but also in other cases, we have full certifications on these issues. It's also widely used, again, okay, I don't repeat this, I've just said it. It is efficient also because its intrinsic properties towards caffeine make relatively low amounts of energy are needed to get caffeine extraction. It appears to be the most commonly used, and again, as I said, within the use of methane chloride, we are very marginal in amounts. What we have done in this brief study was to start from measuring how much methane chloride is left in the coffee powder and how much it is transferred from the coffee powder to the drink, to the coffee cup that was prepared in both drip coffee and French press. The total samples were 34. 28 were roast and ground, 3 were whole bean coffee beans, and 3 were capsules. Well, we go directly to the results. The European law allows not more than 2 parts per million in the roasted coffee of methane chloride that is decaffeinated with methane chloride, obviously. We have found that all of the samples were well below the EU legislation. To note that the US legislation speaks of not more than 10 ppms as a limit. The average methane chloride content that we have found was 0.127 ppm, or milligrams per kilo, or 127 ppbs, if you want. The median was 59 ppbs, so part per billion. And the transfer rate that we have found in the beverage is in drip coffee an average of 24.7 and a median of 26.8. In French press, a bit higher, but still a substantial reduction, with an average of 41.9, a median of 43.1. We did some trials on espresso prepared on capsules also, but it's out of this work. And we found even a lower transfer rate of around 10%. And we are still working on this issue. Right now, here you can see what is the ppb content of the various samples. The average is brought up by the two samples that were slightly higher, but still definitely much lower than what the European law recommends us, or obliges us, or correctly. Not speaking about the US, obviously, but again, very much lower. And here you have all the data that were found in the transfer in the various preparations, in drip coffee and in French press. You find them in the proceedings, and I will not read them all here for obvious reasons. So I already, DCM residues in all analyzed samples were well below the regulation, the EU regulation, what states the EU regulation. The brewing processes, no matter if drip or French, and I would also say now, also espresso from capsules, and we will do some trials also on espresso, are reduce substantially the content. So what you find in the powder, then you will more than half it's in the beverage, or even much less. So this is to support the perfect safety of methylene chloride decaffeinated products. Just to get you some examples, some observations more, we found a study from the Indiana state in the US that was speaking of methylene chloride exposure in the Indiana state. And if you breathe in normally during 24 hours a day in the vicinity of East Chicago Marina, would lead to 10 times higher exposure than 4 cups of average methylene chloride decaf. Yeah, and it needs to be underlined that this comparison is not perfect, because in one case we are talking about inhalation, and in the other case we are talking of ingestion. And in the case of inhalation, methylene chloride is a more delicate issue. So there are more risks in the case of inhalation. In the case of ingestion, we have to say that the toxicity of methylene chloride is much lower than the one of caffeine. So this is something also to take note of. Again, thank you to authors, and thank you to Deutsche Kaffeeverband and European Coffee Federation that also helped us in this work. I stop here and leave it to questions. Thank you.